Today we're going to be learning about the theorem of Pythagoras. The Pythagorean theorem states that in a right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. So if we've got a right-angled triangle, ABC, where angle A is the right angle, that's 90 degrees, then the side opposite that angle is what we call the hypotenuse, and it is the longest side of the triangle. It's common to name the sides of the triangle based on the angle that it is opposite. So this side is opposite angle A, so we call it little a. This side is opposite angle B, so we call it little b. And this side is opposite angle C, so we call it little c. So the theorem of Pythagoras says that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So a squared is equal to b squared plus c squared. We can also write this the other way around. If we are wanting to work out what b is, it's easiest to write it with b as a subject of the formula. That means that we make b on the left and everything else on the right. So then it's going to be b squared is equal to a squared minus c squared. Or if we want to work out what c is, we can write it with c as the subject of the formula. So it's going to be c squared equals a squared minus b squared. So if you're wanting to work out the hypotenuse, it makes sense to put the hypotenuse on the left-hand side of the equation and the other two sides on the right-hand side of the equation, and then you need to add because the hypotenuse is the longest side in the triangle. If you're wanting to work out one of the other two sides, then you make whichever one you want to work out the subject of the formula, and you take the hypotenuse squared minus the other side squared. So if you want to work out what b is, it's going to be b squared equals a squared, which is the hypotenuse, squared, minus c squared. Or if we want to work out c, we're going to take c squared equals the hypotenuse squared, which is a squared, minus the other side squared, so that's minus b squared. Now we're going to go and practice calculating missing lengths in right-angled triangles. Okay, so here's an example. We need to calculate the value of x, and we need to round off to 2 decimal places if necessary. Okay, so let's have a look at how we would do this question. Right, so first of all, we need to see where x is in the diagram. X is over here, and it is one of the sides of this triangle. Now, if we look at this triangle, I only know the length of one side. So I can't use the Pythagorean theorem to work out x yet, because in order to work out a side in the triangle, I need to know the other two sides. I only know one of them. So I need to still work this one out, which means I need to look at what I've got over here. So over here, I've got another triangle, triangle ABD. And in this triangle, I know AB and I know AD. So I can use this triangle over here to work out the length of that side. And then once I know that side, I can then use that with the 9 to help me to work out x. So I'm going to start off by working in triangle ABD. So I'm going to try and work out BD. So I'm going to say BD squared is equal to, now BD is not the hypotenuse of this triangle. The hypotenuse of this triangle is AD. So I'm going to have the hypotenuse squared minus the other side squared. So it's going to be 18 squared minus 14 squared. Okay, so now we can go and work that out. 18 squared minus 14 squared, and that gives me 128. Okay, now the reason that I could say this over here is because of the Pythagorean theorem. In triangle ABD, where angle ABD, this angle over here, is 90 degrees. Okay, so we have to make sure that we give a reason. This is a statement that I'm making over here. I have to give a reason for it. Okay, so let's go and finish calculating BD. So BD squared is 128. So therefore, BD is the square root of 128. But now if you try and work out the square root of 128, you're going to get a decimal answer. It doesn't work out nicely. So I'm going to just write it as the square root of 128. We don't round off yet because we're not finished the question. And if I round off early, it's going to cause inaccuracies later on if I'm working with rounded off values. So I don't round this off until I get to the very end of the question. Now, they haven't given us any unit of measurement, so I just say units. Okay, so BD is the square root of 128 units. Right, now I can go and fill that in over here. And I can use that to help me to work out what x is. Okay, so now x is the hypotenuse in triangle BCD over here. So it's going to be x squared equals, I'm going to square these and add them because I'm working out the hypotenuse now. So it's the square root of 128 squared. Now you could actually just write 128 because when you square root and you square, they cancel each other out. So you could just write straight away 128, or you can write the square root of 128 squared if you want to. Either way is fine. Okay, so this is the square root of 128, and we're squaring that. But like I said, you could just write 128, and then I'm adding 9 squared to that. And the reason that I can say this is also because of the Pythagorean theorem. In triangle BCD, and in this case, the right angle is this angle over here. It's angle BDC. Okay, so now I can go and work this out. The square root of 128 squared is 128 plus 9 squared equals 209. Okay, so x squared is 209. Now I need to work out what x is. So therefore, x is equal to the square root of 209, and that gives me 14.46 units. Now, this is where I round off because I'm now at the end of the question. Okay, so I don't round off until I get to the very end of the question. So for that one, you should get 14.46 units for x. Right, now I'm going to give you a couple to do for yourself. Here's the first one you're going to do. Okay, in this example, you need to calculate the value of h. I'm going to give you 1 minute for this question. Okay, so let's go through that example and see what you should have got. So first you need to look at the diagram and see where h is. H is over here. It is not the hypotenuse. We have the hypotenuse, it's 21 meters. We have the other side of here is 12 meters. We need to work out h. So to work out h, I'm going to take the hypotenuse squared minus the other side squared. So it's going to be h squared equals 21 squared minus 12 squared. And the reason I can say that is because of the Pythagorean theorem in triangle FGH with angle F equal to 90 degrees. Okay, so now we can go and work this out. So I have 21 squared minus 12 squared, and that gives me 297. So h squared is equal to 297. Now we're going to go and work out what h is by square rooting. So therefore, h is equal to the square root of 297, and that gives us 17.23, and that is meters. So that we should have got for question A, that h is 17.23 meters. Right, now we're going to go on to question B. In question B, you need to calculate the perimeter of JKLM. I'm going to give you 3 minutes for this question. Okay, so let's go through that question and see what you should have got. Right, so for this question, you were asked to work out the perimeter of this shape. Now, in order to work out the perimeter, we have to know the lengths of all the sides. Remember, the perimeter is the total distance around a shape. So I have to be able to add up all of the sides around the shape, which means I need to know the length of JM. At the moment, I don't know the length of JM. So to work it out, JM is part of this triangle over here. Now I only know one side in that triangle, so I still can't work it out using Pythagoras. I first have to work out what this side is over here, and then I can work out what JM is. So to work out JL, I'm going to use the Pythagorean theorem in this triangle, JKL. So JL squared is equal to, now JL is the hypotenuse, so I'm going to be adding these when I square them. So it's 8 squared plus 15 squared. And the reason I can say that is because of the Pythagorean theorem. In triangle JKL, with angle K equal to 90 degrees. Okay, so now let's go and work this out. So 8 squared plus 15 squared is equal to 289. So therefore, JL is equal to the square root of 289, which is 17 centimeters. Okay, so now I know that this is 17 over here. Now I'm going to go and work out what JM is. So JM squared is equal to, now JM is not the hypotenuse, JL is the hypotenuse of this triangle. So I'm going to have 17 squared minus 7 squared. So JM squared is equal to 17 squared minus 7 squared. And the reason I can say that is because of the Pythagorean theorem. In triangle JML, with angle M equal to 90 degrees. Okay, so now let's go and work that out. So I've got 17 squared minus 7 squared, that gives me 240. So therefore JM is equal to the square root of 240. And that gives me 15.49. And that's 15.49 centimeters. Now I'm not finished with the question yet, because the question wasn't to work out JM. The question was to calculate the perimeter of this shape. So now to work out the perimeter, I need to add up all of the sides around the shape. So it's going to be JK, which is 8, plus KL, which is 15, plus ML, which is 7, plus JM, which I just worked out is 15.49. Okay, now I can go and work that out. So I get 8 plus 15 plus 7 plus 15.49, and that gives me 45.49 centimeters. So that is the perimeter of this. Please take note, I did not add 17 because this line over here is not on the outside of the shape, it's on the inside of the shape. It's cutting across the shape. So I'm not adding the 17, I'm just adding the sides that go around the shape when I work out the perimeter. So that's what you should have got for question B. Right, now we're going to go on to geometry problems involving the Pythagorean theorem. So now we're going to take the Pythagorean theorem and use it to help us to solve other kinds of geometry problems where we're working with angles and things like that as well. Okay, so let's have a look at our first example. In this example, you have got triangle ABD, which is divided into triangle ABC and triangle ACD. You've been told that AB is 15, BC is 9, CD is 16, and angle C1 is a right angle. And you need to prove that angle B is equal to angle A2. Okay, so let's take a look at how we would do this question. Okay, so first of all, if you look at what we've been given over here, we've been asked to prove that this angle over here is equal to this angle over here. That's what our goal is to prove that those are the same as each other. Okay, now in order to prove that, we are going to need to prove that these two triangles are similar to each other. In order to prove that they're similar, not using the angles, because if I'm trying to prove that the angles are the same, it means I'm going to be proving similarity using the sides. So that means I need to know all of the lengths of all of the sides in these two triangles to prove that they are similar to each other. So what I need to do now is I need to calculate the missing sides here that I don't know yet. So first I'm going to calculate the length of AC. So I'm going to have in triangle ABC, AC squared is equal to the hypotenuse squared, which is 15 squared, minus the other side squared, which is 9 squared. And the reason I can say that is because of Pythagoras. In triangle ABC with angle C1 equal to 90 degrees. Okay, so now I can go and work this out. So 15 squared minus 9 squared, that gives me 144. So that means that AC is the square root of 144, which is 12. Okay, so now I know that AC is 12 units. And I can go and fill that in over here. Let's put it like that. Okay, so now that I've got that, I'll be able to use this and this to work out the length of AD in this triangle over here. But first I need to say that this angle C2 is a right angle. So angle C2 is equal to 90 degrees, and I know that because it's on a straight line with angle C1, which is 90 degrees. Okay, so now I know that this is 90 degrees over here. So I can use the Pythagorean theorem in this triangle using the 12 and the 16 to help me to work out the length of AD, which is the hypotenuse. So AD squared is equal to 12 squared plus 16 squared. And the reason I can say that is because of the Pythagorean theorem. In triangle ACD with angle C2 equal to 90 degrees. Okay, so now let's go and work that out. So 12 squared plus 16 squared is 400. So therefore AD is the square root of 400, which is 20 units. Okay, so now I've got the length of that side over there. So I've got the length of all of the sides in these two triangles over here. So now I can go and try and prove these two triangles are similar to each other, because if they're similar, then I can prove that these two angles are the same size. Okay, so now I'm going to do my similarity proof. I start off by saying in triangle ABC, and triangle DAC. Okay, so now remember, I'm going to be using proportion to prove that these two triangles are similar to each other. So I'm going to take AB over DA and see what that's equal to. So AB is 15, DA is 20. If I simplify that, 5 goes in there 3 times, 5 goes in there 4 times, so I get 3 over 4, 3/4. Right, my next statement, I'm taking BC over AC. So BC is 9, and AC is 12. 3 goes in there 3 times, 3 goes in there 4 times, so I get 3/4. Then my last statement, I've got AC over DC. Okay, so AC is 12 and DC is 16. 4 goes in there 3 times and 4 goes in there 4 times, so I get 3/4. So because I got 3/4 for all three of those, I know that the sides for these two triangles are in proportion, which means that these two triangles are similar to each other. So therefore triangle ABC is similar to triangle DAC, and the reason I can say that is because of the sides of the triangles in proportion. Okay, now because those two triangles are similar, I can then say that therefore their corresponding angles must be equal to each other. So angle B is equal to angle A2. And that's how you would do that question. So now we're using the Pythagorean theorem along with all of the other geometry concepts that we've learned. Okay, so now I'm going to give you a couple that you're going to do for yourself. Here's the first one that you're going to do. In this question, you need to calculate the value of x. I'm going to give you 5 minutes for this question. Okay, so let's go through that question quickly. So in this question, our goal is to work out what x is. Okay, now in order to work out what x is, what I'm going to have to do here is prove that these two triangles are congruent to each other. If I can prove that they're congruent to each other, then I can say that this side will be equal to that side. And that's beneficial because if you look at this triangle over here, it is a right angle triangle, and I know two of these sides over here, which means that I can work out the length of AD. So that's the first thing I'm going to do here. I'm going to start off by working out the length of AD, so I have it ready for when I want to say that x is equal to that. So I'm going to say AD squared is equal to, now AD is the hypotenuse in that triangle, so it's 5 squared plus 12 squared. And the reason I can say that is because of the Pythagorean theorem in triangle ABD with angle B1 equal to 90 degrees. Okay, so now let's go and work that out. So 5 squared plus 12 squared is 169. So therefore AD is equal to 13 units. Okay, so I can go and fill that in over here. This is 13 units. Okay, now I'm going to go and prove that these two triangles are congruent to each other. I need to check if I can first. So over here I've got a common side. Remember, in order to prove congruency, you have to have at least one side that is equal in the two triangles. So I've got a common side, so that's going to be the same for the two triangles. I've got these angles that they told me are equal, and then they told me that these lines are parallel, which means that I can use alternate angles, and I can say that these angles are equal to each other as well. So I'm going to start my proof by saying in triangle ABD, and triangle CDB, my first statement is going to be that this line over here is common. So BD is common. My second statement, I can say that these two angles are the same. So in this triangle, it's angle D1 is equal to angle B2 in the other triangle. And that I know because they told me, so it's given. And then for my third statement, I can say that angle B1 is equal to angle D2, and I know that because these lines over here are parallel, so these angles, which are alternate, will be equal to each other. So angle B1 is equal to angle D2, and they happen to be 90 degrees. And I know that they are equal because of alternate angles with AB parallel to CD. Okay, so now because I've got my three statements, I've got a pair of sides that's the same, I've got two pairs of angles that are the same, I can now say therefore these two triangles, therefore triangle ABD is congruent to triangle CDB, and the reason I can say that is because of angle, side, angle. Okay, now because these triangles are congruent, I can now draw conclusions and say that the other things, the other matching pairs in the two triangles are the same as well. So that means I can say that AD must be equal to BC. Okay, so over here, BC and AD must be equal to each other because these two triangles are congruent. So therefore, BC equals AD. But I know that BC is x, and I know that the length of AD is 13. So that means that x is equal to 13 units. So that's what we should have got for question A. You had to do a couple of things. You had to prove that the two triangles were congruent, and you also had to use the Pythagorean theorem to work out the length of AD and find out that that's 13, and then you could say that because the two triangles are congruent, x must be 13 as well. Now, you didn't necessarily have to do it in the exact same order that I did it. You could have first proved that the triangles were congruent and then used the Pythagorean theorem. That would be fine as well. You could also have done this slightly differently, that you could have proved that they were congruent and then said that CD is equal to AB, so CD is 5, and then use the Pythagorean theorem in this triangle over here to work out x. That would have been fine as well. Now I want to show you another method that we can use to calculate the value of x in this example that doesn't involve congruency. We still need to calculate the length of AD using the Pythagorean theorem, just like we did with the other method. So I've done that already over here, and we know that AD is equal to 13. But now, once I've done that, instead of going and proving that these two triangles are congruent, what I'm rather going to do is I'm going to identify the type of quadrilateral this is. If I can prove that this quadrilateral is a parallelogram, then I can say that because of the properties of a parallelogram, the opposite side must be equal, which would mean then that x must be equal to 13 because those are opposite sides of this quadrilateral, which I would be saying is a parallelogram. So to prove this is a parallelogram, I have a couple of options. I already know that AB is parallel to CD. So I already have one pair of opposite sides parallel. If I can prove that the other pair of opposite sides is also parallel, then I can prove that this is a parallelogram. Or if I can prove that the same pair of opposite sides is also equal, then I can prove that it's a parallelogram. Now, in order to prove that these are equal, I would need to prove that these two triangles are congruent, which I can do, but it's a little bit more work than it will take to prove that these are parallel, because if you look over here, they told us that this angle is equal to that angle. Now, these angles are alternate, so if they're equal, that means that these two sides over here must be parallel. So that's a quick way of proving that those two lines are parallel. So I can go over here and I can say AD is parallel to BC, and the reason I know that is because these two angles are equal to each other and they're alternate angles. So alternate angles are equal. So now I know that this is parallel to that. Now, because I know that those are parallel, I can now say that this is a parallelogram because I have two pairs of opposite sides that are parallel. But before I can say it, I still have to state that these two sides are parallel because I haven't said that at all yet. So I'm going to say AB is parallel to CD. And the way I know that is because it was given, they told me that. So now because I have two pairs of opposite sides parallel, I can now say, therefore, ABCD is a parallelogram. And my reason is two pairs of opposite sides parallel. Okay, so now I know that this is a parallelogram. And because it's a parallelogram, I can now use the properties of a parallelogram, which means that I can say that these two sides are equal to each other. So I can say, therefore, BC is equal to AD because opposite sides of parallelogram ABCD are equal. Okay, so if these are equal, that means that x is equal to 13 units. So that's just a different approach that you could take that will also get you to the same result. Either approach is fine in this example. You can use the method that involves congruency, or you can use the method that involves identifying the quadrilateral and then using the properties of that quadrilateral. Now we're going to go on to the last question for today. In question B, you're told that in the diagram PQRS is a rhombus with PQ equal to 25 units and PR equal to 30 units. Find the length of QS. Just be aware that over here, PQ's length is shown on the diagram, but PR's length is not. They've told you over here that it's 30 units, but they haven't shown it on the diagram because PR is being cut by QS, so it's difficult to show the length of PR on the diagram. So you have to look at it in the information here when you're working this out. Okay, so you need to work out the length of QS, which is this line over here. Right, so I'm going to give you 5 minutes for this question as well. So let's go through this question and see what you should have got. Right, so first, let's just look at the diagram they've given us and the information they told us. So in the diagram, I can see that I've got a quadrilateral PQRS where PR has been drawn and QS has been drawn. Those are the diagonals of that quadrilateral. They've told me that PQ is equal to 25 units. Now, they gave me information that isn't shown on the diagram, that PR is 30 units. So I'm just going to put that over here so I don't forget about it. Okay, so PR is 30 units, and they told me that PQRS is a rhombus. Okay, now we need to calculate the length of QS. Now, we need to think about the properties of a rhombus that we know that could help us to solve this problem. Now, a rhombus we know has got all sides equal, so that means that all of these sides over here are going to be equal to 25 units. Now the diagonals are going to be important in this one because, as you can see, they've drawn the diagonals in here and they are asking us to work out the length of one of the diagonals, which is QS. So what do we know about the diagonals of a rhombus? I know that the diagonals of a rhombus bisect each other, so they cut each other exactly in half. That means that PO will be equal to OR and QO will be equal to OS. And I also know that the diagonals of a rhombus bisect each other at 90 degrees. It's different to other parallelograms. It's only the rhombus and the square that have the diagonals that are perpendicular to each other out of all of the different kinds of parallelograms. Okay, so that's going to be important to me because if they are perpendicular to each other, if they bisect at 90 degrees, it means that I can then use the Pythagorean theorem in one of these triangles. So I'm going to focus on this triangle over here because I have that length over there. It means I don't have to then say that another side is equal to 25 to be able to do it. I can just work with the one that I was given. So I'm going to focus on this triangle over here. So I need to say that these are perpendicular to each other because that's how I can then justify using the Pythagorean theorem. And I also need to know the length of another side in this triangle to be able to use the Pythagorean theorem. Now, I am trying to work out what QS is. So if I work with this triangle, I can work out the length of QO, and because I know that the diagonals bisect each other, it means that OS is equal to QO. So if I can work out QO, I will be able to work out the length of QS, the whole thing. But I need this length over here. But they did tell me that the length of PR, which is this whole diagonal over here, is 30, which means that PO is going to be half of that because this is a rhombus and the diagonals bisect each other. So I'm going to start off by saying what I can about the diagonals here that will help me to actually work out the length of QS based on the fact that this is a rhombus. So first of all, I'm going to say that these are perpendicular to each other because that is why I'll be able to use the Pythagorean theorem. So PR is perpendicular to QS. And the reason I know that is because the diagonals of a rhombus, in this case is rhombus PQRS, bisect at 90 degrees. Okay, so now I know that this is 90 degrees over here. Okay, because they are perpendicular to each other. Now next, I need to know what the length of this side is so that I can use this side along with that to work out what QO is. So I know that PO is half of PR, and the reason that I know that is because this is a rhombus and the diagonals of a rhombus bisect each other. They cut each other in half. So if PR is 30, that means that PO must be half of 30, which is 15 units. And my reason here again is going to be that the diagonals of rhombus PQRS bisect at 90 degrees. Okay, so now I know that this length over here is 15 because it's half of 30. Now I can work in this triangle over here the triangle PQO using the Pythagorean theorem to work out the length of QO. Right, so now I can say QO squared is equal to, now QO is not the hypotenuse, so I'm going to take the hypotenuse squared minus the other side squared, so it's 25 squared minus 15 squared, and that I can say because of the Pythagorean theorem in triangle PQO with angle O3 equal to 90 degrees. Okay, so then QO squared is equal to 25 squared minus 15 squared, which gives me 400. So therefore QO is equal to 20 units. Okay, so now I know that this is 20 units. Okay, now the next thing I need to do is I need to work out what the length of QS is. Now, because this is a rhombus, I know that the diagonals bisect each other, just like I used for working out the length of PO. It's going to be the same concept now, it's just I'm going backwards. Now I've got the length of QO, now I need to work out the length of QS. So now I can say that QO is equal to OS, and it's equal to 20 units. Okay, the reason I know that those are both equal to each other is because of the diagonals bisecting each other in a rhombus. Okay, so now I know that this is also 20. Now, if both of these are 20, it means that QS has to be 40 units. So that's what we should have got for question B, that QS is 40 units. And that's how I use the Pythagorean theorem. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.